really delighted to be here. It's a unique opportunity for me. I spent about 1 month in India. At this time, normally I spend 2 months. So we were in Kanchipuram, standing in queue for 6 hours for temple. I got sick. Anyway, um, it's really amazing that all of you are interested, and Professor Arumugam immediately accepted when I said I would like to talk to in a different topic. And I must apologize in case you already know Raman effect. You already run Raman spectroscopy. Kindly excuse me. And maybe you can add some more incidents which I may not be able to tell. Before I start, I must tell you something how I got attracted to Raman. As I was saying that I did the MSc in Madras Christian College. In those, I don't know now, in those days we had to go to University of Madras, that's in Guindy, I think Guindy campus. It was called AC College of Technology, that 1960. We had to do experiments there under Professor G.N. Ramchandran. It was not compulsory. So most of my friends will go and see a movie, but I will not do that. So I learned how to do X-ray, which was very, very useful when I went to France. Even the French people were surprised how an Indian can do X-ray. The next experiment was on Raman effect. It was very long. I don't know. In those days, I don't know how Raman did it. You'll see it. So we have to first calibrate. You have a lamp, you have some spectrometer, whatever it is. So you must know the so-called wavelength of the light. So you put a standard iron, which is done by some people. Take a photograph. The photograph will be a strip of paper. Then you take some 0 centimeter, measure the length. And each length equal to 5,550 angstroms. Then one more. Then you put benzene. That's what he did, actually, Raman. Then we put benzene, then take another, go to the dark room, develop it, wait. It took about 4 hours. So by the time I went to Perambur, I was so hungry, I reached at 6:30. But I was the only chap who did that. Then I was wondering, then after, just before exams, there was a notice board that Presidency College is organizing a talk by Professor CV Raman, 1960, January or February something. Our exams were in March, April, so everybody was busy preparing. Actually, I was not sure I'll pass my MSc. It was so trembling. It's the first batch in Madras University, so many books to read. And I said, let me go and attend the talk. So I was the only chap sitting last row. All were big shots with turbans and suits and all that. I didn't understand a single word of what Raman said. So I didn't take notes because what will you take notes if you don't understand anything? Then when he was going out, he saw me. "Oh, young man, what are you doing here?" he said. I said, "Sir, I'm an MSc student. I want to do research under you." "You want to do research under me? I've read all my papers." I said, "No, sir, I'm so busy preparing my exams. So I don't have time. So write a letter to me. I'll send you the papers. You won't believe. I just wrote a 10 paisa in those days, inland. Sent me a whole bunch of papers, most boring papers, I can tell you. It's about mridangam, violin, and all kinds of things. I said, my God, how can this fellow get a Nobel Prize on mridangam and all that? I didn't understand anything. Then, after I passed my MSc, I wrote to him. He said, "Okay, I offer you a scholarship, 50 rupees per month." My father said, "At least you get 150 rupees. We cannot live anymore." So I educated you up to MSc, try to get 100 rupees. Fortunately, I was admitted into Atomic Energy Training School. It was 150 rupees scholarship. So I asked some seniors. They said, no, you better don't go to Raman. He's pretty old. He doesn't receive many funds in Bangalore, and you have to do Gurukulam work. You may have to go to his house, wash his clothes. That's how he is. He's a very arrogant and very powerful person. I felt sad. Then I think then my life turned completely different. 76 or so, I had a chance to do Raman effect on my sample compared to an IBM sample. And it was proved that my sample was the best thanks to Raman effect. Because Raman, let us say you have a compound, I'll tell you what it is. Let us say you have a compound AB. And when you make a compound AB, you may not be able to make AB exactly. It will be AB 1.002. It's called stoichiometry, off stoichiometry. So that I could detect using Raman effect. I didn't do that. I knew this could be done, so I went to a Raman spectroscopy lab, and then I did that. Then we compared IBM sample. IBM sample showed lots of peaks. So IBM people were surprised that my sample was very good. And from that onwards, I try to interact and try to do Raman effect on my sample. So that's the introduction, how I got interested in Raman. So, yeah. So let me go through the speech now. I don't have a pointer. And if I move away, you can't hear also, I think. Okay, next one, please. How does it go? It goes automatically? So there are some good books, actually. There's one book by G. Venkatraman, and another one, CV Raman, by A. Jayaraman. I was lucky to have met Dr. Jayaraman, who was the last student of CV Raman. He's from Madras also, Pachapas College, actually. Then he went to Bell Labs, etc. It's very strange. Jobin Yvon is a French company, with whom I collaborate. They made lots of Raman spectrometer. And they used to tell me, in India, why don't you make? This is all made by French, and quite a few times, Jobin Yvon company was selling quite a lot of Raman spectrometer. So there are application notes in website, if you can see them also. The next one, please. So I'll tell about early days of Raman. Then he became an accountant. Then he became a scientist. Then he took science as a pastime. That's why he started wondering. You see, there's no lab. He said, okay, let me do something. Okay, there's a violin. Okay, what is a string? What's a drum? What can I learn from that? The sound is a basic subject in physics too. Then he started, then something happened to him. He looked at the sea, that is what you might have read. Raman saw the blue color of sea and got Nobel Prize. That's what you say. I'll tell you how it is. Then he discovered a mysterious radiation. I'll tell you about it. Then I'll tell you innumerable applications which Raman would have never thought it will happen in life. Nobody would have thought Raman effect will have application all over the world. So then I will summarize. Next one. So he was born on Thiruvannaikkaval, Trichy. It's a pity I went there. There is no statue, no remembrance, and no museum of nothing for him. Then his father was, they're quite rich people, actually, some accountant and all, his father. So he was transferred to Visakhapatnam. Then he joined the school. Then again they got transferred somewhere. Then he joined Presidency College, Madras. 1904, he got BA gold medal, first rank. He first in everything, Sanskrit, physics, Tamil, whatever subject, everything first. Incidentally, don't feel bad if you don't stand first, because I have many instances in my life. People who are just average can become top class scientists. People who are top class, a guy who studied with me, Madras Christian College, he topped in all subjects, much more marks. He could never enter Tata Institute. He failed in the interview. So there's nothing to do with marks. But it doesn't mean that if you don't get high marks, you will are bad. But if you get high marks, you will be a brilliant student also. So it's also important. And just earlier. So in those days, you go for ICS, the British days. When you are first rank, automatically the British guys in the Presidency College, they will recommend you write ICS. But then you have to go for horse riding. Then you must be strong, but he was very weak, so he failed the medical exam. He was so happy that he failed because his interest was in physics. So he joins MA Physics, Presidency College, Madras again. But he never attends lectures. Professor Jones, there was one professor there, gives full liberty to move into the library. So I also heard there is a nice library here, and the lab, I hope some people have labs. He gets hold of several books and looks for solutions. not mentioned in the books, which is quite rare. Then he was always enamored by light. So he was observing the light falling on a oblique slit. Then the light gets diffracted, etc. Then he wrote something. He was the first student in his college to write an article to publish in Philosophical Magazine, which is quite tough. I mean, even now it's quite tough to get published in Philosophical Magazine. So he was the only guy who had that credit. MA, first rank, he bags all the prizes. His heart is set on science, but there's no opportunities. See, even now I know many people suffer. I do meet in Trichy and other places, quite good student, there's no opportunities, so luck also plays a part in life, I know that. And his elder brother was in financial civil service, and he said, why didn't you write this financial? So he wrote that. Topped the exam, and the interview also he came first. So he's on the mind, at the back of the mind, physics is still there. But his brother said, why don't you become a financial accountant? You'll get a good job. So he goes to Calcutta, not London. Gets married to Lokasundari. There's a big joke that he got married mainly because he'll get an extra marriage allowance, 105 rupees, you see. But his mind still in science. What will he do? He's in Calcutta doing finance and accounts. So his mind is still in science. The next one, please. Then what he used to do is take a tram journey to office. There's a routine life. If you have been to Calcutta, you'll see Indian Association for Cultivation of Science. It was founded in 1876 by Dr. Sarkar. It was a nationalist in those days, before independence, you understand. So there are many people in India, South or West or Bombay or Calcutta or Delhi, people who are interested that Indians should do science. So this man was very much interested, and he modeled it after Royal Institution in London. But there's nobody to come. Sarkar passed away, disappointed. At that time, Raman heard about it. Then he enters the scene. And Sarkar's nephew, Amritlal, was there. So he entered, said, we are waiting for you, Raman. We know you will come. So where were you all these years? We are waiting for you. Here are the keys. Come and do whatever you want. Do whenever you want. Anything you want. But what is there? That's what he wanted, but it's not a big lab. It's just starting. So what was the lab there? Let us see. He stays in Calcutta, 1907 to 1917. Then by doing this, at the same time he started teaching. Then he became professor of physics at Calcutta University, 1917 to 1933. What was he doing? Early morning, after coffee, you will go to by tram to this institutes established by Sarkar. He will do some research. 9:30 a.m. to 5 p.m. accounts, 5 p.m. to 10 p.m. to research, and then come home. So what did he do? We don't want to do in detail, but this one is what you'll see in the streets, left-hand side, right-hand side. This is called Ektara, used by sadhus. So these poor people trying to do music just on a string. I tried myself. Impossible. I can't even play Sarigama there. I don't know how they play this. So he said there is some kind of a tension which is important. So, somebody is doing something? Thanks. So a wire in tension is attached to a board. Then I put different kinds of weights. Then the wire is plucked, the board vibrates at twice the frequency of the wire. So he found out a relation between the weight and the frequency. So it was not there. So, it's not a highbrow of physics, but he started getting interested in each and everything, okay, which is very rare. Next one. Then he saw violin. He imitated a violin. He made a kind of a big rod there and a kind of a bow and string. Then he rotated. So then he found this is very, very useful strength, the tension. When you change, as you know, if you see a music concert or Ilayaraja or A.R. Rahman, I don't know, whatever it is, so they'll start tuning the violin. So then he made a relation. This is even now it's known. It's called Raman curve. but it's a very classical subject, so people don't read this anymore. Next one. Western drum. See, it's maybe your children like Western drums. Dum 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 dum. Okay, I don't like it. I like some jazz, but not all the time. Why? You see, there's a scientific relation for that. You see, it's not very pleasant because there is no relation between in the vibrations, which you'll see an image. The next one. So there's a whereas in mridangam or tabla, in on one side of tabla or mridangam, you'll see a leather, and there is a black that thing. Voila, that's the one. It contains iron powder and something like that. So the density is varied because of this. That's the original idea of Indians, I feel. Because it's not there in Western drums. In Western drums, you'll have just a straight leather and with tension and hit with a stick, stick with some ball to do the dum dum sound, okay? That's all. But here, so what happens is when you put a chalk powder on mridangam, you'll get some harmonics, which cannot be seen in Western drums. So that was discovered by him. So he got interested in any damn thing, any simple thing. He was very curious. So that's what we have to note now. So you cannot say, I'm not saying that I myself would have also complained in my life, oh, I want oscilloscope, I want automatic skiing. He cannot do that. He has to do with whatever you have, okay? So that's the originality. Next one. Then suddenly he said he cannot do this. The people started hearing about him. He resigned the job. So Pali professor offer for Ashutosh Mukherjee. He's a well-known person in Calcutta. There is a college on his name. He was offered a professor, and people objected because he never had a doctorate degree. He kept on doing some research. He's a qualified accountant, actually. But still, Ashutosh Mukherjee liked him. He made him a professor. So he resigned his lucrative job. So he was getting 1,000 rupees as a financial accountant. Now he's getting 600 rupees. Okay. And teaching and research, shuttling between science and college and association. And he often will miss the tram, so he has to take a taxi to home. So many times he rushed by taxi to come home. Then he started getting interest in light in 1919. So what happened? Let us see. So what is light? Actually, I'm sorry, some of the slides were meant for school children. I gave a talk to a school, Besant School or something, in Besant Nagar or somewhere. So some of them will be elementary, so I'll go very fast. It's a form of energy, small part of... But here people are there without science degree also? Okay, so it's fine. So please stop me if you don't understand. Please stop me if I'm going very fast, okay? Because I'm not a regular professor like you. You see, the scientists are sometimes bad speakers. Light is a form of energy, small part of electromagnetic radiation, so that itself is a big story. And these are electromagnetic waves, so it can be reflected, transmitted, refracted, scattered, can be polarized. And light propagates in vacuum as waves. So you must understand polarization, that's very important. But sound is also a wave, sound waves. Light also is waves, everything is wave, but light has got a polarization, I'll tell you. Okay, the visible light is what we see. The units are in nanometers, okay, some 380 to 780, 850 or something. Just about that, you have infrared, radar, shortwave, gamma rays, which very short, etc. So the whole spectrum is electromagnetic radiation. Our eye is sensitive only to this much of, which is called VIBJR, if you're violet to red, okay. The next one. So what is, so sound is also waves, as I was telling you. So when when you demonstrate sound by going up and down, whatever it is, a wave means going up and down, okay? So that the distance between the crest is called wavelength. You don't have to remember all that. But light has got, in addition, an electric and magnetic field associated with that. So that's a very important discovery in those days by Maxwell. Actually, it was done by Faraday, which is, that in case you don't know about Faraday, that will take half a day to tell. He's an uneducated person. He was a bookbinder. He was carrying books to a professor. And one day the professor was very busy. He said, you just wait outside. And so this fellow was reading the book. That's how he kept on reading the book. He had his own ideas. He discovered so many things, including a fan and motor. What all you have is all due to Faraday, who never went to college. Okay. So anyway, but he had an intuition that he had electromagnetic waves, and later Maxwell put an equation on that. Anyway, so you imagine you have a finger like this, something is going like this, okay? Whatever vibrates like this cannot go, okay? Only whatever vibrates like this will come like this. So if I put another things like this, I won't see anything. So we say we are crossing the light. We don't see any light. This is a polarizer. Some crystals can be found in nature, which is a polarizer. So electromagnetic waves goes ups and downs like this. When you put a first polarizer, it will allow the radiation go to only in one direction. Then we put the same crystal, that violet stuff, the opposite way, it cannot go, it will stop. The light completely stops. So it's an important property of light. Okay? Next one. This is another application. Light scattering, people knew before Raman arrived in the scale, people knew that light scattering varies as frequency to power 4. So red light has less frequency. You can either call it wavelength or frequency. Both are same, okay? So red light has less frequency than blue, so it is less scattered. It travels more. That's why you have red light. So even, especially in England or Europe, you see the lights are, you have a lot of fog. So the car can stop easily because of red light. That's how the red light stop came. That is the origin. The origin is actually physics and Western countries, because they were having bad weather all the time. Blue scattered a lot, so sky is blue. Okay? So when you see the sky, when you go up, when the sky is blue, because blue scatters a lot. If there is no air, no scattering. That's why the space is dark. So when you can see when the people send the rocket, goes up, then you see nothing, you don't see anything. Okay? Sky is blue, scattering in air, sea water is blue, just reflection of sky, said Lord Rayleigh. That is, sky is blue and water is also blue. Why? So Lord Rayleigh did the Rayleigh scattering, is well known, but he did it for sky. He didn't think of much. He said, everything is the same. But Raman was not satisfied. So that is the very critical point, you see. In my own life, in anybody's life, we see data, and you will see in the conclusion of a paper, this must be similar to that. Then they will finish it off. That's why you must start thinking. So how can it be similar? Why can't it be different? You may be wrong, but there's nothing wrong in thinking the opposite way, for at least for 2 days, 1 week, 15 days, 20 days, 1 month. Then you know that you are discovering something different. Okay, so he started thinking, how can it be like this? So we know that air contains oxygen, nitrogen, etc. So we can call it atoms or molecules. So Raman thought there should be molecules in water also. So as light is refracted in blue sky because of oxygen, nitrogen, etc., there in water there must be molecule which must be refracting light. That's why it is blue. So a typical thing is he was invited to London as in those days. I mean, the British were not so bad. They were so bad, of course, everybody knows, but they are not so bad. Some of them are not at all bad. So they were encouraging scientists, And people who are very good, they were taking them to Oxford to introduce science. So he went to England. On the way back, he came by ship. Of course, in those days, there was only ship. So it comes through Suez Canal, Egypt, the Mediterranean Sea. So which is, I was lucky to go through that area. So I know it's really blue, really, really blue. It's very, very different. The next one. So what do we do when you travel? You watch a movie, you watch a WhatsApp, right? But he didn't do that, So we went abroad, as I was saying, to attend the universities in UK. He was boarding this, I found out the name of the ship from his history. It's called SS Narkunda at Southampton. London is here, Southampton is here. Then you have the France here, then it comes below this, goes down to Italy, a little below Italy, Egyptian canal, then comes. It was struck by the beautiful color of this sea. So he decided it has to be water molecule. See, that is the thing, when you can say he's adamant. And that's how the science goes. And many times I also had some kind of a feeling of making a compound. I said, no, I should not make it that way. But the whole book, everybody in my lab said, no, make it that way. I said, no, I'll do it very different. I put some argon, oxygen, I found a new effect. It's you can say you're adamant, but that's how you have to go. You have to be adamant and stick to the point. See, different thinking. So he said he started wondering. It is due to molecular scattering. So molecules are scattering like air. Water molecules can also scatter, and he always had a pocket spectroscope. You see, in those days, if you put the spectroscope along the sunlight, you will see lots of light, lots of different colors. Okay. Immediately had an idea nowadays most of the flights are direct flights, but I remember when I went first to Paris, it stopped in Tehran. Immediately I went out, what can I buy in Tehran? Can I buy something new which I don't know? Can I buy a scarf? The next stop was Rome. What can I? No, he was not like that. He was carrying a notebook and pen. He started writing a paper. What a difference between us and him. Then adding to Bombay, he wrote another paper. He posted at Bombay first. Immediately it went to London, Nature, it got published. And he came back. He was selected as Royal Society in 1924. Ashutosh Mukherjee was so happy. He said, what next? That's where Raman's very adamant character comes. Of course, it's Nobel Prize. It's crazy, Just because you publish a paper, Lord Rayleigh has already said it's scattering, but he never said molecular scattering in water. And at that time, there's another guy was also working, Compton. So he had 2-3 students. They're all telling Raman, so be careful, sir, Compton scattering's come. Now, don't worry, we will rush. We will get the Nobel Prize. Come on, all of you work. And he had band of people. And some of the names are given there. K.R. Ramanathan, Venkateswaran. K.S. Krishnan was the director of National Physical Laboratory. I had a chance to see him from a long distance, He was a great scientist also. Systematic observation of light. So he has to prove. So he started using different liquids. Then, in some liquids, there'll be impurities. So when you put a light, there'll be what is called luminescence. Okay? So they told him, no, you have impurities. You have not discovered anything. It's always because of impurity. So you'll see the next slide maybe. So that's called fluorescence. It is feeble. I told you polarization. So the fluorescence will not have polarization. But Raman scattering, which we are going to call Raman effect, Raman shift or Raman light, Raman effect, as a polarizing effect. So he said it must be original. It's not due to impurity. It is due to some electronic level sitting there, and somewhere or other I'm able to get it because of molecular vibrations. And he didn't have it was all very, very small, because I don't want to go into detail. Raman effect is very, very small, very weak. So you need a very powerful light to start. Now we have laser. See, so that if you have chance to go to IIT, just go to physics department or anywhere, laser in something like in 2 minutes, you can get the light scattering of benzene, which took 6 hours in those days. So how do you get powerful light? Next one. He said, let me use sunlight. In India, we have no problem. But sun moves, no problem. There's so many workers, You put 3 hours, every worker there, ask him to keep on shifting this mirror. This mirror, you keep on shifting. All the time. No, it's okay, thank you, sir. All the time you get sunlight. He made a window in his lab, and he projected it on his liquid, and then observed the wavelength. Next one. So sunlight, then you put a filter, then the scatterer is a liquid, then scattered light comes like this. It will be violet plus other colors. So you have to again remove the violet. Then the violet alone will come. Then you put green filter. Then you get green light if present, that will also come. So that's how we found out. I'm not talking in terms of numbers, I'm talking in terms of colors, okay? So different colors were seen depending on the liquids. So he said it is something new, not seen before in lab. He called it's a mysterious radiation. I mean, if you see something which you have not seen before, it's very difficult to prove that you are the first person to see. People will think you are crazy. Immediately your friends will say, even now, it many happens to my life. No, you made a mistake. Something wrong in your measurement, or some impurities are there in your sample. That's why, because in one of my samples, the resistance reduced by 1 million when I applied magnetic field. I remember my director was passing through the lab. He was saying, I said, oh, please come. That you can be. Please come, I see 1 million. Oh, no, Mr. Suri, you are making a mistake. There's a short circuit in your voltmeter. Connect the voltmeter properly. He said. I said, no, I connected properly. It's 1 million change. So that's a problem. When you see something new, nobody will believe. But it's for you to make sure that you are done a correct experiment and repeat it and prove that you are right. So this is a way of saying, if it is Rayleigh scattering, it will be here. Frequency shifted band will be somewhere else. So he was sure that this was not seen by Rayleigh. This is very different. The next one. So he was very busy, February 1928. He tested more than 60 liquids, because you have to show that, otherwise they'll say, oh, only in benzene it will happen. Will it happen in toluene or something else, or kerosene or whatever it is? And it is polarized. So it said cannot be fluorescence. Now he wrote a paper, it's no more mysterious. This is the original effect. He sent a paper to Nature exactly in time before other guys, because in France I learned the French people were also trying to do that. In fact, what I learned from a French professor, they were very kind. They knew that Raman did first, so they supported Raman. And another story is, French people didn't like British. So they didn't want a British man to win the Nobel Prize. They want an Indian to win the Nobel Prize. That's the story also. But anyway, the credit certainly goes to Raman for having shown that there's a special radiation comes out when the light gets scattered by a liquid and several liquids. Next one. So this is a simple diagram. If you don't understand, it's not very important, So in any compound, there is, if you have a liquid, it is under so-called rest. We call it ground state. Okay? You don't do anything, etc. It may be moving because of atoms will always move, in room temperature. Then you disturb it by putting light. Then the light will be absorbed by electrons, and they will get energy. They'll go to another excited state. One way of saying, people who don't know science at all, you're sitting in second second line, second row of chair. Somebody pushes you, you come to the first row. And if it is a spring, then when the spring leaves, it goes back to the second row again. See, something like that. So you get an energy push by the light. Light is a form of energy. We know that very well. So it goes to the another electronic state. Then it comes back. During that, the atoms also move, and that creates another level, and that is how you see a Raman scattering. Okay. This is how we did. So this is an old kind of an instrument, which is really, if you go and do it now, you may not even see the effect. It was quite tough. So in fact, when we did in Madras University during my college, it was really quite tough. Then it's Raman with students, and nobody believes, so he demonstrated to students, and many people came around. They started talking about it. And first, 1928, he decided he will give a public lecture. And as I was telling, the British were not all bad, They could have suppressed him, really, but they did not. They gave me a knighthood in those days. That is Sir CV Raman, okay? They immediately told his secretary, please book my tickets to Stockholm by ship. Because in December, all the British guys will go to England for Christmas, and he won't get a seat. They said, why? No, I'm going to get Nobel Prize in December, book this ticket. So people said, crazy, you just published a paper. No, book 2 tickets for me and my wife. That is something very special about Raman. So how dare he said book tickets, people were laughing at him, but 1930 he got Nobel Prize. So the next one. So then he said bye-bye to Calcutta, then welcome to Bangalore. He became director of Indian Institute of Science. He attracts engineering students. Actually, there is one north. Then, even with him, he did something. I don't want to go into detail. It was called Raman theory. It seems it's used in electrical engineering. I don't know anything about it. This is the which I visited in Bangalore. It was 1948. Now it is called Raman Research Institute. The next one. This is the instrument I used in. I had a collaboration thanks to Indo-French Center in Bangalore, Raman Research Lab. You see the complicated instrument I showed with Raman just sitting in a small thing. Now you see here so many. This is a big laser. Delors actually is a French company. Delors, that's a French company. And that little bit of a blue, that's a cryostat, which will cool the sample. And just right below is a microscope, because we have to first focus the light using a microscope and put my sample. I bought some crystal, some special crystal in which we didn't know anything about Raman effects, so we were lucky to discover some new effect. And some signals are connected by the big black box. That's a spectrometer, and the signals are detected by photoconductor, modern stuff. Then you all the all electronics, counters, very modern stuff. The whole instrument is mounted. It's in Bangalore. It's made by Indians. I mean, the instrument is imported. The whole setup is made by Indians. It's mounted on sand. Should not be any vibration. So mostly we do experiments after 9 p.m. There is no vibration in the hall and other things like that. Just to tell you that this was done actually 1990s. So 1975, I've been doing once in a way Raman spectrometer in collaboration. Because I'm not a specialist. You have to really build this equipment. What is the advantages of Raman effect? See, when you do analysis, you have to prepare the samples, like your blood test. When you go to a blood test, for certain blood tests, she'll take the blood and put it. Otherwise, she has to prepare. You might have seen her shaking a lot, putting something, rotating, and all that. There's no need at all for Raman effect. Okay, you can do it on solids, liquids, gases, and there are portable Raman effect now. You can take it to the field and do it, and it's very straightforward. If you know roughly the characteristic of material, the interpretation is very straightforward. Let us say you put idayam nallanai. Okay, idayam nallanai. You put idayam. I told the MSc fellows in IIT, but they don't do it. I said, put idayam nallanai and show it to the student. You'll get a spectra. Now, you go to another shop, another nadar company or shop, who contaminates, who mixes, who cheats you. You put that oil, the spectra will be different. In 5 minutes, you can say that guy cheated you with contaminated oil. So it's similar things. The cereals are now coated with something in India. In France, we import cereals from India. Earl, sesame. There was a big newspaper advertisement, don't buy from India. I was so scared, I didn't know. So I told the IIT people, no, buy sesame and you dissolve it in some liquid and do Raman spectra. If the sesame is coated by some organic stuff, the organic stuff will show different peaks. And the pure one will not show. So very easy to detect, very, very easy. That's why I said straightforward interpretation. Next one. There's so much of application and Raman effect. First, if like the one I did in Bangalore, I made a new material. I want to know what it was, so I characterized that. And when you study as a function of temperature, you can see the interaction of magnetism on light. You can learn so many new things. Okay, that's purely fundamental physics. Magnetism, also superconductors, also I did some work. Then when you do chemical synthesis, also you can follow the chemical synthesis by doing Raman effect. When you, let us say you're adding A, B and C, and you do the Raman effect. You know the Raman effect of A and B and C. So if you keep seeing the same thing, that means you have not made a compound ABC. You're still having A, B and C unreacted. Then you heat it, I don't know, you put a pressure, then do the Raman effect. You see the new Raman spectra. Within 20 minutes, you know. Then you know that you made a new compound. See, so many people have used the chemical synthesis to follow the chemical synthesis using Raman effect. Then biomedical, I'll show an example. I did some work in that. Then forensic, then pharmaceutical, also same thing, all chemical involvement. Next one. Yeah, this is what I wanted to show you. Is idayam oil in India really pure? So this is the oil. And the edible oil, this is not from idayam oil. That fellow should not put case on me. This is some American stuff. So when there is this peak, which I put a big circle, keeps on changing, that shows the impurity, goes away. And the next one. This one, I did some diamond-like carbon. I had some collaboration with Trivandrum. There's a nice institute, biomaterials, Chitra Tirunal Institute of Biomedical Science. They have made in India heart valve, okay, using titanium. Then we told them that titanium, if you put heart valve, when you have cholesterol in the blood, it gets slightly deposited on the valve itself, so which is very bad. So we found in France, I mean, not by me, I did the characterization of the samples. The French engineer he did diamond-like carbon films. So he doesn't know how to characterize, so I characterized it. Then we told the Indian government, we'll put it on your heart valve. Then the cholesterol will be washed away because the diamond-like carbon is so smooth. When you put something, it will not stay. It will not stick. It will just move away. So that is, but you have to characterize the diamond-like carbon coating. So which is done, as I told you, within 1 hour. We made different kinds of samples using different settings of an equipment. How do you make diamond-like carbon? Diamond is just carbon, as you know. But if you tell the women, they don't like it. They say, no, diamond is jewelry, GRT and all that. But it's not GRT, it's made from black carbon. So you take benzene or cooking gas from your house, that's what you use, and put it in a vacuum jar and open it, then put some electric voltage, the gas will be cracked. You crack the gas, the CH4, etc., etc. The hydrogen will go away, only the carbon will stay. You can put a glass plate. Then on the glass plate, you'll see a thin coating, depending on the hydrogen you have. So that will be very hard, very, very hard, that you cannot scratch it. And at the same time, smooth. What you have learned in life is whenever there's a things are hard, scratching, it will not be smooth because that's obvious. But exactly opposite, diamond like carbon, which is very hard, that is you can't scratch it. At the same time, it's smooth. What do you mean by smooth? That is friction coefficient is very low. It's a dry friction, not liquid. So any cholesterol which is forming on that, it will just move away. It cannot stay there. There's no friction offered. But to find out whether my samples are good, I have to do the Raman spectroscopy. So that's a simple. This one, this is to follow the cancerous tissue. It cannot detect cancer, Raman effect. But if people said there is some cancer, then people have. This was done by one of my Sunita. When I was in USA, she did that using a Raman effect. As soon as some changes happens in the tissue, compared to healthy tissue, you know there's some kind of cancerous cell. And when you give a treatment, that particular signal will reduce. And removal of the tissue is not painful to the patient. It is not a remedy, but it will tell you whether it is cancer is going down or increasing. So it's a direct application also. This is a portable Raman spectrometer. What is the use of that? Next one you will see. You can also check Lalita jewelry. You see, identification of gems. Using a portable Raman spectrum, which I showed you, when they tell you, so this is very expensive topaz, but that will give us, in 5 minutes you can tell you. Citrine blue, a yellow colored natural quartz, can be passed off as the more expensive topaz. See, if you go to gem dealers in Panangal Park area, they'll tell you this is a good one you buy. But you take a spectrometer and show, you'll see that it's not the real one. So that's an application for gem people. Then this is used in USA, New York subway system. You see, when you have the drug, they put the drug in a plastic bag along with some bleaching powder. That fellow will say, no, I'm carrying bleaching powder. It's white. Everything is white. So the police, it seems, they have a regular checkup once in a way. They put this Raman portable spectrometer. They'll see immediately different signals. So it is being used in a police. What was discovered in 1930s in a small lab using a liquid and a small spectrometer by Raman, used in New York. This is a portable Raman. See, it weighs less than 1.8 kilo. They move it over the powder, suspected powder, then they know immediately it's a drug. Future, I think quite a lot. Graphene electronics are coming. Nano electronics, I just visited IIT, physics department. They have a very good setup of Raman. They are doing a nano electronic, nano diamond, etc. Some big project has come, you might have seen in the paper. So they are doing, they are making use of Raman spectrometer every day. Then solar cells, that is also called amorphous silicon solar cells. So very strange. In Japan, when I visited the Panasonic solar cell, the solar cells are being made, and silicon amorphous have different structure. So the Raman effect will be different. The solar cells keeps coming. If it is not a good one, ching, then sit down. That fellow, the Japanese throws away the cell. Just on making a chapati machine or something like that. So that is also, I don't think Mr. Raman ever imagined when he discovered that will be used. So there's enormous applications of this simple Raman effect. And how is it? Because he's a brilliant student. He was to work as an accountant, but his mind was always in research, observation, curiosity, because people said it will be impurity. He said, no, it may not be impurity. Okay, I will prove it's not impurity. He will purify the benzene and showed it's not impurity. So it's not fluorescence. It is, then it has to be polarized. So he showed it's a polarization. So he went on pursuing his, some kind of a thoughts he had. So which is not so common among everybody. Okay, so wide range of application, and now There's established world-class research institute everywhere in Bangalore. Is a top-class institute, and everywhere. I mean, even foreign countries, there is a Raman Institutes made on his name. Thank you so much.